Welcome to the Explainer. So if you've been staring at dense study notes on data architecture and just feeling completely overwhelmed, you are absolutely in the right place. Today, we're going to take those dense, complex concepts and transform them into a really intuitive visual journey. By the end of this Explainer, I guarantee you aren't just going to memorize these terms, you're going to actually understand them, and you'll be totally ready to crush your exams.
Okay, let's dive right into this. Here is our syllabus for today. First, welcome to the warehouse. Then, types of data warehouses. Third, introducing OLAP. Fourth, the 5 OLAP operations. And we'll wrap up with key comparisons and takeaways. We're going from the massive macro view all the way down to micro-level data manipulation. Section 1. Welcome to the warehouse, the foundation of data. I want you to picture total organizational chaos for a second. Just imagine decades of sales receipts, HR files, and marketing metrics scattered across hundreds of different, totally disconnected computers. I mean, it's a mess, right? To make any sense of it, all that data needs a structured home. And that brings us right to our core definition. A data warehouse is a centralized system designed to store, manage, and clean large volumes of data collected from different operational systems for historical analysis and decision-making. The two absolutely crucial keywords you need to remember here are centralized and historical. By taking all that chaotic data from multiple sources, cleaning it up, and structuring it in one central hub, users can finally perform highly efficient queries on the past to help predict the future. Now, you might be wondering, why do we go through all this trouble? Well, it really boils down to two main goals: producing statistical results for decision-making and providing lightning-fast data retrieval, even when you're dealing with literally massive data sets. The ultimate goal of all this storage is speed and insight for management. This rock-solid, structured foundation is exactly why we're going to need some really powerful analysis tools a bit later on. Section 2, Types of Data Warehouses. Finding the right fit. Because centralized storage can take on a bunch of different shapes and sizes depending on what an organization actually needs, let's rapidly move through the 7 main variations. First up is the Enterprise Data Warehouse, or EDW, which stores data for the entire organization, the whole shebang. But, sometimes you need something a bit more focused, which is where a data mart comes in. This one is just for a specific department. Think of a university keeping its HR data totally separate from student data. Then we have the Cloud Data Warehouse, which is absolutely perfect for scalability. A big data warehouse handles both structured and unstructured data. A virtual data warehouse provides unified access to information without actually making physical copies. Pretty cool, right? A hybrid data warehouse gives you flexibility by combining on-premise servers with the cloud. And finally, a real-time data warehouse provides immediate insights from continuously streaming data. Now, what's really interesting is our 8th type, the Operational Data Store, or ODS. We need to explicitly contrast this against a standard data warehouse because this is definitely going to show up on your exams. The key idea here is that an ODS is for real-time, day-to-day operational activities. A data warehouse, on the other hand, is built for historical, analytical information. Make sure you keep that distinction locked in. Section 3. Introducing OLAP, the Analytical Engine. All right, so we've built our warehouse, but it begs a pretty obvious question, doesn't it? We have all these massive amounts of structured, historical data neatly stacked on our warehouse, but how do we actually analyze it all at once? How do we bridge that gap between raw storage and complex, multidimensional analysis? The answer? OLAP. That stands for Online Analytical Processing Server. It's a software technology that allows users to perform multidimensional analysis on information from multiple database systems simultaneously. So the crucial point here is that OLAP is the interactive tool that lets us actually play with the data cube we've built. Section 4. The 5 OLAP operations, manipulating the cube. All right, this brings us to the climax of our explainer. This is where we learn the actual spatial movements we can perform on our massive data cube to get the exact insights we're looking for. There are 5 major operations you absolutely need to know: drill down, roll up, dice, slice, and pivot. And hey, don't worry if these sound a bit abstract right now. I'm going to guide you through each one and we'll master them together using some really simple visual analogies. Let's start with drill down. Spatially, I want you to think of this operation as stepping down a concept hierarchy or adding a new dimension to get highly detailed data. For example, say you start by looking at sales data for the entire year of 2026. You drill down to quarter 1, then you drill down to the month of January,
And finally, down to the specific day of January 15th. Honestly, the easiest way to remember drill down is to simply think of it as a zoom in. You are zooming in for more detail. Now let's see how this builds in reverse with the roll-up operation. Roll-up is climbing up the hierarchy to aggregate your data and reduce the dimensions. So we start at January 15th, roll up to the whole month of January, roll up to Q1, and finally back out to the entire year of 2026. The easy memory trick here? Roll up equals zoom out. You're zooming out for more summary and less detail. If you pit these two opposite concepts directly against each other, they are incredibly easy to lock in for your exams. Drill down increases detail, moves down the hierarchy, and adds dimensions. It's a zoom in. Roll up decreases detail, moves up the hierarchy, and reduces dimensions. It's your zoom out. Next up is dice. The dice operation selects a subcube from the OLAP cube by selecting 2 or more dimensions. Imagine literally carving out a specific multi-dimensional chunk right out of the middle of a larger data block. For example, asking the system to show you data where the location is Delhi or Kolkata and the time is Q1 or Q2. You are dicing out a specific block of information using multiple criteria. Now compare that to Slice. Slice selects a single dimension or value from the OLAP cube, creating a new subcube. For instance, you tell the system that time is exactly fixed to Q1, and this brilliantly illustrates the difference. By fixing just one single dimension, it acts exactly like taking a knife and cutting a single flat layer right off the data block. I gotta warn you guys, this specific distinction between dice and slice is incredibly important for exams. Just remember the criteria. Dice selects 2 or more dimensions. It's multiple selection criteria. Slice selects a single dimension or value. Only one dimension is fixed. Dice is a chunky block, slice is a flat layer. Our fifth and final operation is pivot, which is also known as rotation. Pivot rotates the current view of the OLAP data to obtain a new perspective. Now, the underlying data hasn't changed at all, but let's say you just sliced a flat layer off your data cube. You can then pivot that layer to flip your rows and columns. It gives you a totally fresh perspective on the exact same numbers, making it so much easier to spot new trends. Section 5, Key Comparisons and Takeaways, the Exam Cheat Sheet. Okay, we've gone from massive, organization-wide warehouses all the way down to the exact spatial operations we use to analyze the data. Now, I want you to lock this summary table into your memory. It perfectly captures the core takeaways we've covered regarding OLAP operations. Drill down is your zoom in, roll up is your zoom out, dice selects a multidimensional subcube, slice cuts one single layer, and pivot changes your visual perspective. Honestly, if you know this table, you know OLAP. So let me leave you with this thought. Now that you understand the mechanics of it all, once you've centralized your data in a massive warehouse, drilled down into the microscopic details, and sliced the perfect analytical layer, what new perspectives will you pivot into view? The analytical possibilities here are literally endless, and now you have the exact tools you need to uncover them. Thanks for joining me on this explainer, and happy studying.